Hi guys, these are a few of the questions that you found hardest for the diagnostic questions, so I just thought I'd go through them so you've got some worked solutions. This first question asked for the rate of change or the slope of this line, so it was basically asking for the gradient of the line. So in that case we want rise over run, change in y over change in x, and in particular here it's sort of the distance in feet over the time in minutes. And I can do lots of different things. I could pick, for example, point D and point E and find the rise and the run here and work it out. Or I could pick any 2 points. And actually, for me, I think it's probably easiest to pick like this point and this point, right? Because they're going to give me smaller numbers. So if I look at my rise here, how much is 1 square on this graph? Well, it's worth 10 feet if I check the units carefully. And my run is equal to 1 minute. So in that case, my rise over my run, my rate of change, my gradient, my slope, they're all the same thing, is going to be 10 feet over 1 minute. So I think that should be C then as my final answer. Right, the next question asks us to look at the line 3x plus 4y equals 3. And it's trying to decide, is it parallel to 3x? And does it cross the x-axis at 1, 0? So to know whether it's parallel to 3x, what we're saying is if it's parallel to 3x, it's going to have the same gradient as 3x. So it's really asking, does it have a gradient of 3? It's not easy to tell right now when it's in that form, the standard form, whether it has a gradient of 3. So what I'm going to do is I'm going to rearrange it into the form y equals mx plus c, because then I know that the number in front of the x is my gradient. So I'm going to take 3x plus 4y equals 3. And the first thing I'm going to do is take the bit involving the x across to the other side. So I've got 4y equals minus 3x plus 3. That's almost in my y equals mx plus c form. But instead of having y on my left side, I've got 4y. So I need to divide everything through by 4 now to have just y. So then it'll be y equals minus 3 over 4x plus 3 over 4. And that's now in my y equals mx plus c form. And now it's in that form, I can see that the gradient of this line is minus 3 over 4, which means it definitely isn't parallel to 3x because it doesn't have a gradient of 3. The next one asks me to say, does it cross the x-axis at 1, 0? To know if a point rests on a line, we can just substitute each of those coordinates into the equation and see if it works out, basically. So here's my x coordinate, here's my y coordinate. I can substitute those values into either of these two equations, but I'll be honest, I think the standard form is probably easiest in this case. So let me rewrite that out. So it's 3 times 1 plus 4 times 0. And it should equal 3. That's what the equation says. So let's check if that's true. 3 times 1 is 3, plus 4 times 0, which is 0. And yeah, 3 plus 0 does equal 3. So it works out, which means I know that this point rests on the line. So what we're saying is that equation doesn't have a gradient of 3, but it does cross the x-axis at 1, 0, which means it should rest in this area here in region C. The next question asks us to find which of the lines is not parallel to y equals 2x plus 7. So again, if we're talking about a gradient, an equation being parallel, it needs to have the same gradient. And here, that number in front of the x, the minus 2, that's our gradient of this line. So what we need to do now is double check which of the other equations does or doesn't have a gradient of -2. And, some of these are easy. For example, if I take a look at C here, this is practically in the y equals mx plus c form. And I can see my gradient, it's always the number that's in front of the x once it's in that y equals form. So here I've got a gradient of -2, so it's not C because that is parallel. Let's now try multiplying out for D, this bracket here, because I need to multiply it out for it to be in the y equals mx plus c form. And if I do that, I'll have 2 times 1, which is 2, minus 2x. And again, here's my gradient. And it's -2, so that one's parallel to that line. If I check B, then I need to multiply that sort of negative into this equation. So I'll have y equals -8, and then a negative times a negative is a positive. So that's plus 2x. So that's my equation that's not parallel to that line, because that +2 isn't the same as -2. So it has a different gradient, which means it's not parallel to that line. So B is my answer. Let's just check that A is parallel to it. Should be, and we can tell. At the moment we've got 3y, but to be able to find the gradient I need it to be in the form y equals something. So I'm going to divide everything through by 3. Then I'll have y equals -6x divided by 3 is -2x. And then 8/3, I'll just leave as 8/3. And there again, yeah, our gradient is -2. So B is definitely our one that's not parallel to that other line. Okay, for this question, it says 3 of the following statements about the diagram are true and 1 is false. Which one is false? So let's take a look through. The first one says the gradient of the line AB is 5/12. And actually, before we can even get going, that's a positive gradient, right? It's saying the gradient is positive 5/12. But when I look at this line visually, I can just see it has a negative gradient because it's going down from left to right. So A has got to be my false one. So I suppose that was nice and easy. So I think we'll stop there. And then the final question I'm going to go through is this question, which asks us to find the length of the line joining those 2 points. There's a formula in the formula booklet for this, and one that we've also gone through. And it is y2 minus y1 squared plus x2 minus x1 squared. So basically we find the change in the y, the change in the x, and then we use Pythagoras to figure it out. So for us, let's call this one here our number 1 coordinate, this one here our number 2 coordinate. So that means that will be our x1, y1, x2, y2, and then I can just substitute that into this formula. So I will have y2, which is -4, minus 2 squared plus 3 minus -1 squared. It doesn't matter if I had my coordinates the other way around, it's still going to give me the same answer. If I carry on working through, then I have -4 minus 2, which is -6. 3 minus -1 is like 3 plus 1, so that's 4. And then if I work that through, -6 squared is 36. 4 squared is 16. 36 plus 16 is 52. So that means the length of the line joining those 2 points is the square root of 52. So my answer should be A. And that's the final question I'm going to go through for now. But if there are any other questions that you'd like me to review from the diagnostic questions you did at the end of last week, just drop me a message and let me know, and I can make another video.